Yeah, so one of the important things for us is to really facilitate communication amongst various NASA facilities. So we have the Michoud Assembly Facility, which is a manufacturing facility that's in New Orleans. But a lot of the engineers who design the equipment that's being manufactured are located in Alabama at another NASA facility. So they're not always in the same space, and communication can be difficult between the two because one party does not necessarily see what the other is doing. So we've got the digital twin that is this digital intermediary that both parties can look at. One operator in Michoud could be wearing HoloLens 2 and communicating inside the facility, and the person in Alabama can be on their PC, see where that person's located, get a video feed of their HoloLens 2, and get a really deep understanding of what problem they're trying to overcome. So one of the big challenges for us was to get a multiplayer game working where the HoloLens and the PC were both running in the same simulation in multiplayer mode so that they could collaborate digitally inside the same digital artifact.
Yeah, and an interesting point too about the photo that you see here. Obviously, this is the Civil and Tech office, as you can see from the sign there. We couldn't show the actual facility because of the sensitivity of that data, which we'll talk about a little bit later. But here's a sample of like the floor levelness. And we talked just a minute ago about how they actually roll the assembled core stage out of the facility. And so one of the things that they wanted to do with the digital twin is actually understand the levelness of the floor. So as they're moving it, they can adjust the platform for any dips or height changes in the floor so they don't cause damage to the rocket as it's laying on its side and as they're moving it out of the facility. So this
Yeah.
is an example of seeing that from a HoloLens.
I think one of the things Greg didn't mention earlier, that this facility has been growing. So since its inception, they've been adding buildings to it. So not all the floors are at the same level and not everything. I'm sure it wouldn't be built this way if they built the entire facility in one go like now. So it's a bit of a Frankenstein when it comes to sort of all these different assembly facilities with different sized doors, floors that are at different amount of levelness or evenness. So I'm sure it's a challenging facility for them to navigate through.
And that's something that, to be honest, I hadn't really considered where, I mean, with the digital twin and all that, obviously laying out things in advance or testing or even being able to check where things are in real time. But to have that precision to check how level the floor is for these rocket engines for placement and all that is fantastic. And that's great to hear.
There's even a problem that one of the engineers raised, which was we're on the Gulf in New Orleans. So there are tides, which I didn't think affected manufacturing facilities. But since each of these floors on piece of concrete are raising and lowering with the tide, and these pieces they're welding are so large, the tide changes will actually take a weld joint and a piece of metal that is joined, and they'll separate as the tides change and then come back together. So they even have to worry about the tides in the manufacturing facility when they're welding these large assembly pieces together.
Now that has to be just an extraordinary amount of data to hold digitally and then bring together.
Yeah, it is. And that was when we started this project, that was one of our big challenges is how do we really go about getting access to the data? But not only that, we don't want to force different tenants of the facility to use a system if they're already using one system, and the different tenants all use different software systems and have different data points. And so we really put a lot of thought into this. And this is where we started exploring the idea of a digital thread. And it truly is a new way to think about data integration. So we don't want to actually move the data like to a central data warehouse. We want to leave it in those source systems. And you get lots of different benefits of that. Like it's authentication control down at the originating system so that tenant that owns that system, they can control who gets access to it instead of granting access and moving it to a central location. And now that data team is the one responsible for that. So what we've done is design the system that uses REST APIs and is able to communicate to any other software system that has a REST API. And as you can imagine, and you can kind of see here a small sample of it, there's a lot of different systems and it gets very complex very quickly. And so it's really important when you're working in an engineering problem in an engineering space to understand the effects of a change in an engineering system and what all that could affect if you make that change. So there is a sample right there on the screen, kind of towards the middle of the diagram. There's a green little circle there that has the G1 asset. So that's a representation of an asset in the facility. So if you were to make a change to that, what does that actually affect? And everything around that is data and different systems that all have a relationship to that asset.